Dear Professor, I would like to submit my homework for sharp number 1 about write a function to solve forward kinematics of a two-link planar robot. The topic of this homework is write a function to solve forward kinematics of a two-link planar robot. Given conditions are these. Next, I will introduce how to solve. As the figure shows, the end of first link, we can create a new coordinate system. The x1 axis in the line with the first link. This a line. The x2 axis is in line with the second link. Now, we can see the first link is at an angle theta to the x-axis. So the OX1 equal L1 by cosine theta. The OY1 equal L1 by sin theta. Like this, for the L2 link, the second link is at an angle phi plus theta. So the x1, x2 equal L2 by cosine theta plus phi. The y1, y2 equal L2 by sin theta plus phi. So we can get the x equal L1 by cosine theta plus L2 by cosine theta plus phi. The y equal L1 by sin theta plus L2 by sin theta plus phi. In MATLAB, we can define P equal two-link Q. The two-link is defined by me. For the forward kinematics, it means that given theta and phi, find the x and y. In MATLAB, we could define P equal two-link Q. And for the inverse kinematics, it means that given x and y, find the theta and phi. In MATLAB, we can define Q equal two-link P. When the angle more than 0, the link counterclockwise rotation. When the angle less than 0, the link clockwise rotation. The function named toLink is defined to make one input Q and return an output P, Q int, and P output. The length of two links are defined L1 equal 8, L2 equal 9. This means the angles are extracted from the input vector Q. Theta is the first angle. Phi is the second angle. For this, the x and y coordinates of the end effector are calculated using trigonometry. X is the horizontal position, calculated as the sum of the projections of both links along the x-axis. Y is the vector position, calculated as the sum of the projections of both links along the y-axis. The position P is a vector containing x and y. For this row, it means a new figure is created. For the hold one and hold off are used to allow multiply plots on the same figure and then finishing plotting. This, for the first link is plotted from the orange 0, 0 to the end of the first link the link L1 by cosine theta, L1 by sin theta. The second link is plotted from the end of the first link to the end effector position x, y. This is mean these neighbors named as x and y. And this it means the plot is customized with neighbors for the x and y axis and limits for the port arrow to ensure the port is within -10 and 10 on both axes. The video, let me see the video. The video shows that the programs and the figures how to operation and display. This one and this one. As the figure shows, Q is defined as 0 and 0. Two links are never become a line. When Q is defined as pi 4 and pi 3, the first link counterclockwise rotation. About point about point 0.78 0.7954 right. The second link counterclockwise rotation about 1.0472 right. The end effector of the robotic arm is at the coordinates 3.32748 and 14.3502. When Q is defined as -1 and 2, the first link clockwise rotation 1 row right about 16 degrees. The second link counterclockwise rotation 2 right about 120 degrees. The end effector of the robotic arm is at the coordinates 9.18514 and 0.841471. We can see these 3 points have visually shown the arm configuration for these angles. This is my introduction of homework for sharp number 1 about rate affection to solve forward kinematics of a two-link planar robot. Thank you.